An experiment was set up, shown below. It was observed that after leaving for several days, the liquid in the gas jar has had the same color throughout. This was the result of the movement of, okay, what do we have inside the experimental setup? We have got aqueous copper 2 sulfate at the bottom and we have distilled water on top. Aqueous copper sulfate is a blue color solution and distilled water is of course a colorless clear solution or clear substance. So since we know that from kinetic theory of matter that the particles of the distilled water possess internal energy with which they are going to move and they're going to diffuse into here. And aqueous copper 2 sulfate is made up of copper 2 ions and as well as sulfate ions, and they are also going to have internal energy with which they are going to continue to diffuse throughout the liquid. And of course the blue coloration of the copper 2 sulfate is going to spread across everywhere, and of course colorless solution when it mixes is still going to appear bluish in color. So the entire jar, okay, is supposed to appear uniformly bluish in color. And this was as the result of the movement of the copper ions, sulfate ions as well as the water molecules. Okay, so diffusion occurs when particles use their internal energy to move from one place to another. So in this case we are talking about water molecule, copper 2 ions as well as sulfate ions, which is an anion. So all the particles of copper ions, sulfate ions as well as water molecules would all diffuse into each other to produce a uniformly blue color solution. So the answer for this is copper ion, sulfate ion and water molecules.